Okay. So what are we discussing in the previous classes? Were you there in the last class?
Yes, sir.
What was the topic we were discussing?
We discussed about how to separate oxygen from water, distillation
Acha.
process.
So we are discussing about the preparation of oxygens. Yes or no?
Yes, sir.
So our last topic was preparation of oxygen. So naturally we can get the oxygen, okay, in the nature, in the atmosphere, and how we get. So this is the oxygen cycle. So here plants, trees can absorb, okay, the carbon dioxide from the atmosphere, and they releases the oxygen, and it releases the oxygen. So this oxygen utilized by the human beings and animals, they inhale the oxygen and they exhale the carbon dioxide. Again the carbon dioxide will be taken by the plants, again they convert, they release the oxygen. So naturally we can get the oxygen, okay, from the plants in the nature. But okay, can we prepare this hydrogen artificially? Means yes, okay, along with the natural oxygen we can also prepare the oxygen artificially. So those methods we have discussed in the last class. One is by heating oxygen containing salts like chlorates. On heating the chlorate, say potassium chlorate, so here we can get the oxygen, okay. And by the thermal decomposition of oxygen of metals, so metallic oxides also when heat, okay, thermal means what? Heat. Decomposition means what? Breaking. So on heating the metal oxides also breaks, okay, splits and releases the oxygen. And third one we discussed like hydrogen peroxide. Hydrogen peroxide also decomposes into water and oxygen. And we also discussed like electrolysis of water. This electrolysis means what? The process of decomposition of a chemical compound by passing electricity. By passing electricity we can dissociate or we can decompose, we can split the water into hydrogen and oxygen. So that is also called electrolysis. And last and final process, this electrolysis and the next process, both are used okay, in the preparation of oxygen in large scales, in the large scales. So this is okay, by the fractional distillation from the air. So these are the methods of preparation of oxygen that we studied in the previous classes. Yes?
Yes,
Right,
sir.
right. So today, now we are going to discuss about the properties of oxygen. So physical as well as chemical properties of oxygen. Okay. So in the chemistry, generally what we do, any matter, we have the two types of properties. One are called as the physical properties, and the second one are called as the chemical properties. Physical properties means what? Which like how they appear, okay. So external features are called as a physical properties, okay. Internally how they behave, like how they react with other elements is comes under the chemical properties, okay. So in the chemistry we are going to study about two types of properties. One are called physical properties and the second one are called chemical properties, okay. So now first let us see the physical properties of oxygen. So here you see oxygen is a colorless, odorless and tasteless gas. Okay, see here we have lot of oxygen in the atmosphere. Okay, so when you stand in the nature, okay, so do you, okay, you are taking the oxygen. Do you see any color of oxygen?
No, sir.
No. So there is no color. Do you smell anything in the oxygen?
No, sir.
No color. And you taste it like you speak. So generally, okay. Can you taste the oxygen?
We
No.
can't take, sir.
Yeah. So physical properties. The one of the important properties is that the oxygen gas is a colorless, odorless, and tasteless gas. Okay. That is the first property. Okay. Then come to the second property. Here generally you know that oxygen is a gas. Anyone can say that oxygen is a gas. Okay. but oxygen can be converted into solid as well as liquid also. Okay, oxygen can be converted into solid and liquid also. Okay, so the meaning is what? Oxygen can exist in three states. Okay, that is gaseous state, that you know, along with under certain conditions. Remember here, along with under certain conditions, oxygen can be converted into liquid and can be converted into gas also. Is this clear to you?
Clear, sir.
Now here just now in the gaseous state we discussed that oxygen has no color. It is colorless. Okay, but when you convert the oxygen into liquid state or solid state, it appears to be like pale blue, means light blue in color. Okay, the liquid and the solid forms of oxygen, how are they in color?
Pale blue color.
Pale blue. Okay, very light blue in color. Okay, next oxygen changes from a gas to a liquid at a temperature called minus 182.96 degrees Celsius. So see a temperature minus 182.96. Do you know what is with a minus 182.96? Okay, so you see here, this is minus 182.96, means what? It is very cool. Okay, normal temperature in the summer, our temperature goes to, in summer I am saying, our temperature goes to above 45 degrees Celsius. How many? 45 degrees Celsius. Okay, now here in the winter, okay, this is winter now. In the winter, normally in Hyderabad, the temperature falls to 13 to 14 degrees Celsius also. 13 to 15 degrees Celsius. Okay, 13 to 15. So that only we feel very cool and we use the sweaters and okay, black hats while sleeping, so many things. And where 30 degrees Celsius. Okay, when you go to the now at present, if you go to the Delhi, okay, the temperature in the nights okay, comes to approximately 6 degrees Celsius. How much it comes to? 6 degrees Celsius. If you go to the Kashmir, okay, now in the month of December to January, their temperature goes to 0 degrees Celsius. Temperature goes to 0 degrees. At that time 0 means what happens? The water will be converted into the ice. Water is converted into the ice. Now water, if you keep the water, the glass, if you want to drink a water, you take the water and keep outside for few minutes, then that will become ice. So that is 0 degrees Celsius. Okay, in the Kashmir, okay, the Dal Lake is there, Dal Lake. Okay, and that lake now in the winter season, now the December to January, that total lake means what? Which is water. So that becomes ice upper layer, and the people skate on it. Skating, you don't know?
Yes, sir.
They skate on this one. So now if you take when you go to the ice cream shop, and you take the ice cream from inside. Okay, so from the deep freezer, have a deep freezer. No, when you open, it looks like from the smoke, like it's coming here from inside. Okay, such a deep freezer will be there. Did you see it right? Ice cream shop.
Yes, sir.
So there, that in there, okay, the ice cream shop, the strong means ice cream when you take from the deep freezer, that is minus 15 to minus 20 degrees Celsius. How much it is? Minus 15 to minus 20 degrees Celsius. Now like that, if you go down till where minus 182.96, okay, so you are going till where, see, at Kashmir, if you see 0 degrees Celsius, there only the water becomes ice. And ice cream, when you are taking from the deep freezer, then the strong solid like ice cream will be there, that is minus 50. Minus 15 to minus 20 degrees Celsius. That is too cool. But like that, if you go very cool, then what it becomes here? Minus 182 you unexpected. Okay, if we go there, our body total get freezes. Okay, our blood become freezes, solid. Every part of our body becomes so, like, solids. We don't live. Okay, so such minus 182 degrees Celsius, if you take the temperature, then oxygen can be changes into liquid state. Oxygen can be converted into which state? Liquid state. And from there again you go still down. Still you decrease the temperature. Okay. Then you go to the minus 218. Then that solidified or frozen. Oxygen becomes solid also. It becomes frozen. Okay. So in this way we can change the oxygen. Actually it's a gas. But we can change it into liquid as well as solid also. Is this under normal pressure? Under normal pressure. Is this clear to you?
Yes, sir.
Right. Then come to the this is one more allotropic forms. Allotropic means what? Okay, occurrence of the same element in two or more, okay, different physical forms with the same chemical properties or is called allotropy. Okay, so existence or occurrence of the same element means remains same. If the same element occur in two or more different physical forms, okay, occur in two or more different physical forms, means physically they are different but chemical properties remain same. Okay, so physical form, different physical forms, okay, then that property is called allotropy, and that forms are called allotropic forms. Same element we can get in different okay, physical properties. Like for example, if we see the car, what is car? Car means what? Okay, the car which is have a four wheels and it is totally covered, not like a bike, so we can protect from the sun, air and rain and something, and it can move. That is car. But when you go outside and stand on this road, and if you see the cars, how many cars are there? Okay, different cars are there. Yes or no? All physical properties, just physically means what? By appearance they look different. Maruti 800 looks different. Maruti Wagoner look different. And Maruti, what do you say? Baleno look different. And Breezer, okay, Brezza, okay, look different. So all are cars only. All are having four wheels. All are running with petrol or diesel. Okay, but the appearance physically what they are different. Yes or no? Like that. So like that, allotropy also same. The existence means one element only. If it exists in two or more different physical forms, then that is called allotropy. And here, okay, oxygen occurs in three physical forms. One is called dioxygen. Di stands for two, so we can write O2. That is called dioxygen, O2. Second one is nascent oxygen. Nascent oxygen is what? A single O when it is just produced during the chemical reaction. Just produced during the chemical reaction. That is O. And third one is ozone. That is O3. Okay. So like oxygen, okay, we can get in three different physical forms, and that property is called allotropy. So oxygen occurs in three allotropic forms. One is called dioxygen. Di stands for two. Okay, O2. And second is what? Nascent oxygen. Just prepared, okay, during the chemical reactions, it will be single oxygen. So that is a nascent oxygen. And third one is ozone. You know about the ozone. Okay, so O3 that spread in the atmosphere. Is this clear to you? Chalo, these are all physical properties. If you want to note down or take a screenshot, and you can later if you want to note down, but you have to note down very important points is all. So your wish now. Are you noting down or taking the screenshot?
I took screenshot, sir.
Yeah, what about you?
Sir, I also took screenshot, sir.
Chalo, okay then. So when you take the screenshot, then you need to write this all. Okay.
Yes, sir.
Don't
After
forget to
class,
write.
I will write, sir.
You have to maintain the perfect notes of this one because so many things are there which are not there in our textbooks here. So many things. If you have iron, oxygen, okay, lesson is there. If you see in this 90%, your teacher will not say. You once you check. Okay. So many things we are explaining here. That is IIT Foundation. So you are imparting your excess knowledge to you, which are very very important. So when you go to the higher classes, it becomes very easy to you. Everything you can say before, okay, others says. Okay, so that's what you note down this all the points. Okay, please you take a screenshot now, so don't waste the time. And later, whenever you have a time, so read these okay points and then write it. Okay, so these are about the physical properties of oxygen. Now then come to the chemical properties. Okay, so chemical properties of oxygen. How oxygen react? How oxygen react? Okay, so that is called as the chemical properties. See here, oxygen one of the such element which can react with almost all the elements. Which can react with almost all the elements. Okay, so it can react with the metals, it can react with the non-metals, it can react with the semiconductors like metalloids. Okay, it can react with everything. Okay, so almost all. Okay, so that's what oxygen is considered as one of the most important element. So now chemical reactions, if you see, first one we see the reactions of oxygen with the non-metals. So what are the non-metals? You know, okay, like carbon is a non-metal, nitrogen is a non-metal, sulfur is a non-metal. Okay, these are all are examples for the non-metals which are not a metals, right? Okay, so these oxygen react with these non-metals and form their respective oxides. They form their respective oxides. Means what? If it is reacting with carbon, it forms oxide of carbon. If it is reacting with sulfur, it forms oxide of sulfur. Reacting with oxygen, so reacting form the oxide of nitrogen. Like this, it forms their respective oxides. And here you have to remember the most important point is that the oxides of non-metals are acidic in nature. What is the nature? Acidic. Okay, acids and bases you know, no? Okay, so here they are acidic in nature. Now that we are going to see here. Now see here, reaction of oxygen with non-metals. Non-metals combine with oxygen to form non-metal oxides. Okay, non-metals like sulfur, carbon, nitrogen, phosphorus, all these are examples for the non-metals only. Okay, so all these non-metals, okay, they react with oxygen to form their respective oxides. Example you see here, this is called a general equation. Okay, general equation or word equation. Okay, so non-metal. For example, take the sulfur. See, S means sulfur. This is non-metal, and this is reacting with oxygen. So this is oxygen. When reacting with oxygen, it is forming non-metal oxide. So sulfur reacting with oxygen to form sulfur dioxide. So this is sulfur dioxide. Is this clear to you?
Yes, sir.
Even sulfur can form trioxide also. Okay, sulfur can form trioxide also. When this sulfur dioxide is you need not write, but in your English. Okay, so this 2SO2, this sulfur dioxide, once again it reacts with water to form sulfur trioxide SO3 like this. Okay, so that is also takes place. With the sulfur, oxygen can form two types of oxides. Okay, one is called the sulfur dioxide and the second is called the sulfur trioxide. So here when sulfur is reacting with oxygen, then it is forming sulfur dioxide. Okay, that is one. Now then come to the second example. So this is the first example. Okay, now come to the second example. This is in the second example. Say similarly, carbon forms carbon dioxide. See here, carbon is burning in oxygen and forming what? Carbon dioxide. oxide. Okay, so carbon is a non-metal. It is reacting with oxygen and forming the carbon dioxide. Okay, and even carbon also can form two types of oxides. One is called carbon dioxide, and the second one is called carbon monoxide. Okay, carbon also can form two types of oxides. Okay, one is called carbon dioxide, and second is called carbon monoxide. Dioxide is what? Two oxygens are there. So you can write like this also. Okay, C plus CO2. Okay, it gives rise to 2CO. So this is called mono. Mono means what? Single. Monoxide, single oxygen. Dioxide, two oxygens. Trioxide, three oxygens. Tetroxide, four oxygens. Pentoxide, five oxygens. Like that. Okay, so like this here, non-metals you are given two examples. One is sulfur reacting with oxygen to form sulfur dioxide. Second one, carbon reacting with oxygen to form carbon dioxide. And you see, very important point this one. Note, generally non-metal oxides are acidic in nature. How they are? Acidic in nature. That's the first point. And second point, you know that if they are acids, then blue litmus turns into blue. Acids changes the blue litmus paper into red litmus. You know this one?
Yes, sir.
Yes. Okay. This property also you have to remember. Okay. So that's all about the reaction of oxygen with the non-metals. So if you want to write or you want to take a screenshot, you can take a screenshot, your wish.
Sir, screen is not clear, sir.
Screen is not clear now. It is clear to me. Here I can see whatever Pawan you.
Sometimes it is clear and sometimes it is not clear, sir.
Okay, I'll take this point to the technical team, so they will resolve this problem the next class. Generally it is clear because I can see that recording. Okay, this one. So camera. So there it's showing clear. Is it done?
Done, sir.
Right. Now, so reaction with oxygen with the non-metals is done. Now let us go to the reaction of metals with oxygen. Okay. So reaction of oxygen with the metals. In the previous slide we discussed about the reaction of oxygen with the non-metals. Here we study about the metal. So once again, same, just I told you know, oxygen can react with almost all the elements. So here, almost all the metals also, okay, react with oxygen to form the metal oxides. There what we studied in the previous slide, non-metals react with oxygen to form non-metal oxide. Here, metal react with oxygen to form metal oxide. Okay, so see here, almost all metals combine with oxygen to form metal oxides. So example you see here, this is a general equation or word equation. Now example for metal we are taking the copper. Cu stands for copper. Okay, when copper is heated in presence of oxygen, when it is heated in presence of oxygen. Actually, you know, copper is a brownish, reddish brown in color. Which color that is? Reddish brown in color. Okay, so you take one watch glass. So like this is called watch glass or one beaker. In that you take reddish brown in color. Okay, copper. So you are taking the copper here. This is a copper. For example, you think this is a copper. Okay, and you are heating this one. Okay, you are heating. On heating, then what happens here? Okay, this is a copper. This is copper. Okay, this is copper. See you. On heating in presence of oxygen, here all oxygen is there. No, here all oxygen is there. When it reacts with oxygen, it forms copper oxide. It forms what? Copper oxide. And this copper oxide color is black. Which color it is? Black in color. That is black in color. So the carbon, when it is heated with oxygen, it reacts with oxygen to form the copper oxide. So this is copper is a metal, copper oxide is a metal oxide. So like this metals react with oxygen to form the metal oxide. And you see here generally metal oxides are basic in nature. There what we studied in the previous slide, non-metal oxides. Non-metal oxides are acidic in nature. What we studied there? Acidic in nature. But here they are metal oxides. Metal oxides are basic in nature. Is this clear to you?
Yes, sir.
Right. So in base system, which litmus to which litmus? Red litmus to blue litmus. They turn red litmus to blue litmus. Okay. So generally metals are basic in nature, but there are few metals are there like aluminium and zinc also. These metals when they burn, when they heated in presence of oxygen, they also forms the oxide. They are also called metal oxides. But these metal oxides are not purely basic in nature. They have both basic as well as acidic, okay, properties. Okay. Some elements, some metals. Which metals? Examples like aluminium and zinc. Aluminium and zinc, okay, they are also metals. They when heated, they form their oxides. But these oxides are not purely basic in nature. They have both acidic and basic nature. Such oxides are called amphoteric oxides. What they are called? Amphoteric oxides. Okay, can you see on the down on the screen? Amphoteric. So amphoteric meaning is what? Which have both acidic and basic nature. So this is about the reaction of oxygen with metals. Is this clear? What happened? No response.
Yes, sir.
Yeah, chalo, take the screenshot of this one. I'm moving because the down, the one more sentence is there. Take the screenshot. Done.
Done, sir.
Right. Now, so these are about the chemical properties. So we are not discussing much more chemical properties here. Only few chemical properties only we are discussing here. So then go to the next one. Now this is very important. It's not like oxygen, but it's about the air. It's about the air. So here can you see some pictures here? What are these?
Spoon, sir.
Spoons. What are these? What are those? Those are spoons. Yes or no?
Yes, sir.
But you see the color. Is there any change in the color?
Yes, sir. They are rusted.
Ah, very good boy. Now here you see here these are the which are made up of copper. You can see in our houses, no? Near the while performing the puja or something, we use these copper vessels mostly. Yes or no?
Yes, sir.
Now they are shiny here. Now here see same the copper, but on it what you can see here?
Corrosion, sir.
Now here you see what are this?
Ironed.
How they are now? Bright and shiny. Yes or no? Now how here?
Here they are brownish in color.
Why?
Again, they react with oxygen and they are rusted.
Very good. So here you see students, here these all are okay, here they are in pure state, okay, actual state, but when these are exposed to the atmosphere, like in the moisture or the open air, then what happens after few days, so they become like this. Okay, so why they become like this? Because as already told you that metals are okay very reactive. Okay, and you know that they have the ability to react with the other element. Just in the previous slide you also seen no, the metals react with oxygen. Okay, not only oxygen but they can react with the atmospheric gases. They react with water, atmospheric
Atmospheric gases.
gases. And in the atmosphere so many gases are there. Okay, so they react with the different gases and forms like this. Okay, so this phenomena is called corrosion. What it is called, this phenomena?
Corrosion.
Corrosion. So see here, corrosion definition you can see: when a metal attacked by substances around it such as moisture, air also, gases, acids, etc., that is said to be corrode, and this process is called corrosion. So when you place the metals exposed to the air or moisture or even sometimes acids also, so what happens? They get corrode. Corrode means water that like that they become. Okay, so that is called corrosion. Okay, so here these are the some of the examples of corrosion. Okay, so first we take the silver articles. These all are what? Silver. Okay, silver articles. Silver articles are white, shiny. Okay, look so beautiful. Yes or no? But if you put for a long time in the moisture and air in the atmosphere, then what happens? They react with the sulfur. Okay, present in the atmosphere, and like this they turn, and what is the substance is forming? Black color substance forming on it. That is called the silver sulfide. What it is called?
Silver sulfide.
Silver sulfide. So silver is corroded with the sulfur. Okay, so here you see silver articles become black after some time when exposed to air. So in the air is a mixture of gases, but in what making the silver to become black? This is because it reacts here. It reacts with the sulfur. It reacts with the sulfur, and form this silver sulfide. And this silver, this is a black color. What we can see, this is a silver sulfide. Is this clear to you? So this is one of the example for corrosion. Okay? Right.
Okay, sir.
Now come to the next one. Next one you see here, this is copper. Copper is also getting corrosion, but you can see turned into green in color. Generally this we can see in the bathrooms or water pipes. Okay, so there we can see here. Okay, so here what happens? The copper reacts with the moist carbon dioxide. Here it is reacting with the sulfur, but here copper reacting with water, carbon dioxide, moisture carbon dioxide, and slowly loses its shiny brown surface and gains a green coating. Okay, which coating it forms? A green coating, and this is called copper carbonate. So this is what? Pure copper. Okay, and on exposing this becomes what? Copper carbonate. Copper carbonate is green in color. Is this clear?
Yes, sir.
Yeah, and the last one you know. Okay, last one is iron. Okay, iron when exposed to the moist air for a long time, it acquires a coating of brown flaky substance. Okay, and that is called as rust. That's called what? Rust. So rust is nothing but a oxide. In the moisture oxide, the silver iron is reacting and forming the rust. So this is iron. Okay, and this is what? Iron oxide. Okay, so that is about the reaction of air with the on the metals. Okay, Chalo, take the screenshot of this one. Take the screenshot of this one.
Sir, I took, sir.
Chalo. So with this we'll stop today, and in the next class we conclude this lesson. We complete with this lesson, and be ready. So read what I said is all, because next topic we have very small topic is there. Only small topic is left, that is applications of oxygen, where we use oxygen. So uses of oxygen, but that we discuss in the next slide. So with that the lesson will be completed, and at the same time whatever the time will be left, and in that time I am going to ask you some questions from this related to air and oxygen. Okay, so you have to answer. Is this clear to you?
Okay, sir.
So for that we have to write all these notes, and you read it well, very perfectly, and when I post the questions, you should be able to give the answers to me. Okay?
Okay, sir.
Okay then, bye, take care.